Welcome to the Chapter 5 of the Jack Code jf010e transmission. In this chapter you'll learn about diagnosis processes for this unit. We will include PID lists, code lists, common failures, and system reset procedures. My name is Jared Warren and I'll be your host for this course. It's a great day to fix transmission, so let's get started. Remember, the vehicle is the best dyno you have, so perform all the necessary tests and gather all the data that you need before you remove this transmission. We'll always want to do a bulletin search, make sure the latest programming has been done, and make sure you focus on the customer's complaint to resolve that complaint. Also, you want to go into the global scan, record all codes in all the different modules. This is very important to write all these codes down. In CVT systems, a lot of different modules like the ABS can affect and will affect the transmission operation. So make sure you record all the module codes and keep record of that. Battery and charging system and health check. So you want to clean the battery, reset the battery cables, clean the major grounds. Make sure we do voltage checks on the battery and the charging system before we remove this transmission or before we get too deep into the diagnostics. It's got to be one of the first things we do on any vehicle. Scan data information. It's always best to record a movie so you can review the movie and the PIDs of when this problem's happening so you can see exactly what's going on. Make sure you check the fluid level at the proper temperature. We're going to talk about that a little bit later. And the condition of the fluid. Make sure it's the correct type of the fluid and the amount. We've been having some issues with the Nissan warranty department on their reman units. So if you do use a reman transmission, make sure you use the OEM fluid. And also make sure it is programmed. I would recommend by Nissan. Save all the warranty paperwork and the receipts for fluid and programming just in case you do have a warranty issue. They have been voiding a lot of warranties lately. Alright, so check the fluid in the CVT. We need to make sure the transmission temperature is 122 to 176 degrees Fahrenheit. Use a little small screwdriver and go ahead and push in on this lock here and then pull the stick out. Clean the stick off and then reinsert the stick, and the fluid level should be between the minimum and maximum. The key point here is the temperature. It has to be between 122 and 176 degrees Fahrenheit or the fluid level will not be correct. You want to use Nissan CVT NS2 transmission fluid. Dipstick tube is going to be up here in the front. Here's the hole that the tube goes into. So the stick's going to be in this area right here. So some of the preliminary checks that we want to do. Again, we need to record all the codes from all the modules and write those down. Very important to do a battery voltage check. What I'd recommend is walk out to the car, go ahead and hook your multimeter up to your battery and see what the voltage is before you start the car or even road test the vehicle. Go ahead and write that voltage down. Start the vehicle, see what your charging voltage is. Check your battery cables and ground connections and take care of any issues with the battery first. We have seen some major problems where these vehicles run at 9.5 volts, start just fine, and have no shifting problems. Ratio wouldn't change. The engagement issues, we've had no acceleration or no throttle pedal, all just because of bad batteries. Want to check this transmission case connector for corrosion and broken pins. If you're dealing with electrical codes, after you check the battery, go ahead and remove the transmission case connector and get in there with a mirror, magnifying glass, and look at the case connector and the pins. These things are very small and they like to corrode and break off. So check that if you're dealing with electrical codes before you start breaking out the multimeter. Another thing that does not throw a lot of codes but will definitely affect your transmission is your wheel speed sensors. There's been problems where the wheel speed sensors have corroded or rusted away and you get erratic wheel speed sensors. So the ABS system thinks that you're sliding or skidding the tires, and it's trying to detune the engine so you lose your accelerator pedal. It won't let you accelerate. The RPMs won't raise. Transmission ratio won't change, all due to wheel speed sensor operation. So it's a good idea to get into the ABS section, pull up your wheel speed sensors, and drive the vehicle straight. Make sure all wheel speed sensors are operating correctly and the same speed. And make sure, as always, the latest programming and update has been done. There has been a fair amount of updates done to this transmission when it comes to programming, so it's always best to have the latest program in the vehicle. Let's see, the most common issues outside of the transmission, again, are the bad battery and charging system. The throttle, no pedal, engine won't accelerate. Those kind of things are usually due to a dirty or noisy throttle signal. A lot of times it's a bad connection or bad ground to the throttle, the TPS signal. Also up at the throttle body, we've seen some issues there with the ground of the throttle body motor. Dirty or noisy speed sensors and case connector issues. Most common issues inside the transmission. This is what we see, a pattern failure inside. Flow control valve stuck in the pump has to be the number one problem. We see this most often. There's a couple fixes for this by Transco. It has one, it's a drop-in valve. Sonics also has a reamer and a valve for this. But your main concern is going to want to be inspect that flow control valve. Go ahead and repair that bore however you're going to want to repair it, and make sure you address that issue. Need to make sure you pull all the pulleys apart. The pulley grooves, there's some balls inside the pulley grooves, and these balls like to break up and damage the grooves, and the balls will cause the pulleys from opening and closing smoothly. So you want to inspect the insides of the pulleys. Very, very big problem here. Another thing that fixes a lot of these transmissions after rebuild is just stuck valves in the valve body, contamination in worn bores. Most of the time, you'll want to pull every valve out. Picking these valves is not going to fix your problem, but pull each valve out, clean the valve bore and the valve body, and reassemble it. Usually you're pretty good to go. Has been somewhere in the valve body, but not huge issues on this unit. Usually pulley and belt damage usually is caused from the above items. So if you have a broken belt, usually you're dealing with a pressure problem, or the pulleys are not opening and closing smoothly because the balls and the grooves that they ride in are catching, get slack in that belt, and then it breaks. So if you have a broken belt, you need to find this problem first, what caused it. Checking those three areas: valve body, pulleys, and flow control valve. So here's a PID list. Quite a bit of different PIDs on this transmission. We're not going to go over each and every one of them, but let's go over a few of them here. The VSP. Here, the VSP sensor, the vehicle speed sensor. They also have an estimated vehicle speed sensor. So this ESTM is estimated vehicle speed signal. Then you have your primary speed sensor, PRI speed, and your engine speed signal. So this SEC HYDR SEN is secondary hydraulic sensor, basically voltage. This is the pressure sensor for the secondary. Primary HD or HYDR. This is your pressure sensor voltage for your primary pressure switch. ATF temperature voltage. Let's see here. Primary speed and secondary speed. These are another two that we need to take a look at. These are your speed sensors. slip rev. This is the difference between the engine speed and the primary speed sensor. So this will help you on lockup here. Gear ratio. This is a good PID to watch when you have no acceleration or no change of ratio. Here's your accelerator pedal position. It reads from 0 to 8. So when it's closed, you're going to be at 0. And then when you start accelerating, the levels are going to go up. So like at 1/8 throttle, you're going to be at level 1 of 8. You know, half throttle is going to be 4 of 8. Torque request PID. This is another one you want to take a look at. See what happens if you have like a no ratio change or no engine acceleration. See if this PID's active. Your secondary pressure and your primary pressure. ATF temp count. This is temperature basically converted over to levels or different temp counts. So you'll start out at a certain number, and the number will increase or decrease as temperature changes, and you can convert that over to degrees or Fahrenheit. D gear ratio. This is a desired gear ratio. Also a very good PID to look at. When you have no ratio change, see if the computer is wanting the ratio to change. Stepper motors, they get blamed for a lot of problems. They usually don't have too many issues themselves, but the codes are always pointing in the direction of having a bad stepper motor. Usually those are performance codes. We'll talk about that a little bit later. But here is your desired step and the real step. So these two should match. Lockup pressure, this is a calculated value. There's no way of it measuring lockup pressure. Line pressure. And to continue on, here's target secondary pressure. So if you look at your secondary pressure, you want to look at your target pressure. This is what the computer is wanting. Then you can go back to the other PID for your secondary pressure and compare the two. And this is where it kind of gets confusing. ISO LT1, that's a torque converter clutch valve output current. So this is torque converter valve amperage. Number 2 here is line pressure solenoid. So LT2 is line pressure solenoid amps. Secondary pressure solenoid is LT3. SOLMON1. This is solenoid monitor valve 1, so lockup solenoid, and it's the monitoring amps. So if you're looking at this PID here, ISO LT1, that's torque converter clutch valve output amperage, and you want to measure or monitor the true amperage on that circuit, you'd go to SOLMON1. So those two are basically like desired and actual amperage. And then you have the same thing for your SOLMON2 and number 3. Compare those PIDs. Here we have your range switch. Range switch number 3, 4. There's 2 3s on here, so one's monitoring and one's actually a switch. And we're going to talk about that a little bit later. Range switch 2 and range switch 1. So here's all your range switch wires and signals to the computer. Your brake switch on off just like any other vehicle here. Wide open throttle switch, full switch is wide open throttle. Your idle switch, idle SW. And here's a couple other PIDs. If you're not having any ratio change, you want to take a look at these. STDRWNSW. So this is shift down switch. Shift up switch is the other one right below it. INDL RNG is basically indicator for the low position, indicator drive position, indicator neutral position, reverse and park. So this is for the indicator light on the dashboard or on the shifter. And to continue our PID list, sport mode, here is your stepper motor coils. DC, B, and A are all different wires for your stepper motor. It takes 4 circuits to operate that stepper motor. You can watch these turn on and off if you graph these out. Your lockup solenoid output and monitoring. Reverse backup lights, starter relay, VDC on light. This is usually for like traction control, or it sees a problem in steering angle sensor, G sensor, these kind of things. So this is just telling us the light's on for the DC or VDC, the traction control, and the ABS to finish off this graph. Alright, so now we're going to go over some trouble codes and the different of some of these codes. So P0703 is a brake switch. This is a circuit code. It basically is not seeing the brake switch. We're going to go over these codes and how to test them too, so I'm going to kind of skim through these quite quick. 705 is your range switcher A code. Basically, we'd be checking the range switch. It's saying that the TCM shift lever position is incorrect for the position switches. 710 transmission temperature sensor. This is a fairly big issue on this unit. A lot of problems with the scan tool not being correct. And then 715, 720, and 725 are all due with speed sensors, input, output, and engine speed. 730 is the incorrect gear ratio. And then 740 is the TCC converter clutch circuit. And 744 is more of a performance issue. 745 we have a pressure control solenoid A. 746 is pressure control solenoid performance. So on a lot of these codes, you're going to have like solenoid A circuit and solenoid A performance. Just like here on solenoid B, 776 is a performance, and 778 is an electrical. 840 and 841 are pressure switch codes. We're going to go over all these individually also. We have some more transmission. 845 transmission fluid pressure switch B. 868, this is another one that's very common. Fluid pressure, transmission fluid pressure low. A lot of times this is from the flow control valve being stuck. And then 1701 TCM power supply, low power to the TCM. And these are basically for your reference. We're going to go over these a little bit later too. So let's keep on moving on. Throttle control 1726. This code should pop up more, but it doesn't. They should have a performance for this, but throttle control is a big issue with this trans. 1740 select solenoid. 1745 is line pressure control circuit. Stepper motor 1777. This is circuit. 1778 is more of a performance. We'll go ahead and go over this and how to test upper motors a little bit later. Let's keep on moving. Alright, so transmission failsafe. If the TCM has electrical problems, it's going to put it into failsafe mode. This makes it possible to operate even if there's an error in the electrical system. So basically what you're going to deal with, you're going to have a forward and reverse, and you're going to have no ratio change. So let's say we lose an output speed sensor. You have a secondary speed sensor code. The shift pattern is changed according to throttle position when an unexpected signal is sent from the output speed sensor to the TCM. So what they're basically saying there is it sees an output shaft speed sensor code. It's going to say, okay, we're having a problem, but we're going to go ahead and shift the transmission or change the range by the throttle angle, the throttle percentage. If we lose an input speed sensor, the shift pattern is changed according to throttle position and secondary speed, the vehicle speed. So basically what they're doing here is they're using other sensors to be able to still control the transmission shift pattern off of the throttle and other speed sensors. So if the park switch, if it sees an unexpected problem, it's going to put the transmission into the D position or in drive position. So if we have a temperature sensor problem, it's going to basically put the gear ratio back to the gear ratio before receiving the signal is maintained. What they're going to do there is they're going to try to keep the engine RPMs down, and they're going to limit the gear ratio, try to keep the transmission cool. Now if we have some problems with like the transmission fluid pressure switch A, secondary pressure sensor, secondary pressure feedback control is stopped and the offset value obtained before the non-standard condition. So what it does is it stops the feedback, but the line pressure is still controlled normally. So if you're having a problem with the pressure control solenoid A, line pressure solenoid, if it sees a problem on that solenoid, it's going to stop control and going to put maximum fluid pressure. So secondary pressure, they're going to still control the transmission. But if you have a problem with the line pressure solenoid, they're going to max the transmission fluid pressure. Pressure control solenoid B, if it's seeing an unexpected signal, it's going to go ahead and stop the control and it's going to achieve maximum fluid pressure. If you have a problem with your torque converter clutch solenoid, the solenoid is going to be turned off and it's just going to cancel the lockup. And then if you have like a stepper motor ratio or stepper motor circuit code, it's going to hold the last ratio or the last position where the stepper motor already is. It's not going to move it or try to control the stepper motor since there's a circuit code. So if the lockup select solenoid has an issue with the circuit, it's going to be turned to the opposition and it's going to cancel lockup.